The topic for this video is chemical quantities. The essential questions are how can we find what percent composition of a substance? What is the difference between the molecular formula and the empirical formula, and how do we find each one? So the percent composition is the percent by mass of each element in a compound. So we're going to find the percent by mass of each element in ammonium nitrate, which is NH4NO3. So the first thing we have to do is find the gram formula mass off the periodic table. So we have N, which is 14, H4, which is 4 H's, which is 4, another N, which is 14, and then 3 oxygens, which is 48. So we add that up and we get 80. So that's the total mass of that compound. So then to find the percent nitrogen, each one is 14 and there's 2 nitrogens in there, so that's 28, and we put it over the total, which is 80. Multiply that by 100, and that gives us 35% nitrogen. Hydrogen is 1, and there's 4 hydrogens in there, so times 4. Put 4 over 80, multiply it by 100 to change it to percent. We get about 5%. Oxygen is 16, and there's 3 of them in there, so we multiply that by 3, and we get 48. Put it over 80, which is the total. Multiply it by 100, and we get 60%. So that's how you find a percent composition. To find the formulas of a compound, we have the empirical formula, which is the formula of a compound in the lowest whole numbers. Okay, for example, CH2O. There's not a lower ratio for that. A molecular formula is the actual formula for a compound, so it might be the same as the empirical formula, or it might be a higher ratio. For instance, the same one we had for the empirical formula, a molecular formula would be C6H12O6. I can reduce that ratio, but that is the actual formula for that compound. So the first thing we're going to do is classify each formula as empirical or molecular. So basically we just need to look and see if we can lower the ratio or not. So H2O2, I can lower that ratio. So that means that it is a molecular formula. C2H4, that can be lowered. That ratio can be lowered, so that's a molecular formula. NH3, that cannot be lowered anymore, so that's empirical. Na2Cr2O7, that cannot be lowered anymore, so that's empirical. C3H9O3, that ratio could be reduced, so that's a molecular formula. Okay, so now we're going to figure out how to find each of these. So we'll do some examples. A compound consists of 105 grams of carbon and 35 grams of hydrogen. We want to determine its empirical formula. So the first thing I want to do is take each of those and change it into moles, because we can't compare grams of 2 different substances. We have to compare moles. So I know from the periodic table that there's 12 grams in carbon, so I'm going to divide that out, and that gives me 8.75 moles of carbon. I'm going to do the same thing with hydrogen, but I know for hydrogen it's 1 gram off the periodic table, so that gives me 35 moles. Now, I'm going to divide by the smaller of the two. So the smallest one there is 8.75, so I divide them both by 8.75. I get 1 on the carbon, and I get 4 on the hydrogen. So that means for every carbon there's 4 hydrogens, so that's CH4. Let's look at another one. A compound is 43.66% phosphorus and 56.34% oxygen by mass. What's the empirical formula? We can actually do the same thing and just change those percentages to grams. So I have 43.66 grams phosphorus and 56.34 grams of oxygen. I'm going to use the gram formula mass, which is 30.9 grams for phosphorus, and I get 1.4129 moles of phosphorus. Same thing for oxygen, using oxygen's gram formula mass, which is 16, and I get 3.5213. I'm going to go through the same process. I'm going to divide by the smaller number, which is the 1.4129. On phosphorus I get 1, and on oxygen I get 2.5. So using the same idea, it would be PO 2.5, but I can't do that. So I have to have whole numbers. So I'm going to multiply those each by 2. So that's going to give me 2 on the phosphorus and 5 on the oxygen. So it's P2O5. I can't have a decimal on my subscript. So that's what you do if you get that. The compound in the previous problem has a molar mass of 284 grams per mole. What is the molecular formula? So we found that it was P2O5. All we have to do is take the gram formula mass and divide it by the empirical formula mass. So it tells me the gram formula mass is 284. The empirical formula I can find by adding 2 phosphorus and 5 oxygen, and that's 142. When I divide that, I get 2, which means I need to multiply the subscripts by 2. So instead of P2O5, it's going to be P4010. Okay, a compound is prepared by combining 12.08 grams of sulfur with fluorine to produce 55 grams of SFX, and we want to know what X is. Well, we know that the total has to be a sum of what we put in there. So to find out how much fluorine we had, we're going to subtract, and we get 42.92 grams of fluorine. And now we can go through the same process from the last slide. I'm going to convert these to moles. Okay, I'm going to take the smaller number and divide on both of those. On the fluorine, I get 6, and on the sulfur, I get 1. So that's SF6. What is the gram formula mass of the hydrocarbon? Is 120 grams per mole. What is the molecular formula? So again, we're going to take gram formula mass over empirical formula mass. So it tells me it's 120. I can calculate the empirical using that C3H4. Each carbon is 12 and there's 3 of them, so that's 36. And each hydrogen is 1 and there's 4 of them, so that's 4 and 36 makes 40. So 120 divided by 40 gives me 3, which means I'm going to multiply each one by 3. So instead of C3H4, I have C9H12.